Hi there, so today we're going to learn how to solve some real-life applications of GCF and LCM. Let's do it. Now here's our first problem. 3 bells toll at regular intervals of 15 minutes, 16 minutes, and 36 minutes respectively. Given that they toll together at 2 p.m., what time will they next toll together? So if bell 1 toll for every 15 minutes, that means the next time it will toll would be after 30 minutes. And then followed by 45 minutes, and so on. So this would be the time interval that bell 1 will toll. For bell 2, it says here that it regularly tolls for every 16 minutes. So the first toll would be at 16 minutes, second would be after 32 minutes, and then the third would be after 48 minutes. And the cycle continues. And for the last bell, it tolls for every 36 minutes. So it takes much longer time. So for the first toll, it would be after 36 minutes, followed by 72 minutes, and then the third would be after 108 minutes, and so on and so forth. Now the question is, given that they started at 2 o'clock p.m., what time will they next toll together? Or after how many minutes will they toll together at the same time? So in short, we want to know the number of minutes where the 3 bells will toll together. And that's basically the least common multiple, where these 3 values will meet after some time. That gives us an idea that when it comes to LCM problems, it tells us about where the certain values will meet after some time or after some cycle, and so on and so forth. So if we know that this involves LCM, let's put the numbers inside our L symbol, 16 and 36. And then try to find a common prime factor, or at least 2 of the numbers inside, since this 3 doesn't have any in common. So let's just pick at least two of them. And I can see here 15 and 36, which has a common prime factor of 3. So this will be divided by 3. 15 will become 5. 16 will remain as 16, and 36 will become 12. Now again, let's continue because I can still see 2 numbers with common factor, and that is 16 and 12. 16 and 12 has a common factor of 2. So let's divide 5. 16 divided by 2 is 8, and 12 divided by 2 is 6. Again, we'll still continue since 8 and 6 still have a common prime factor, which is 2. So let's divide this by 2. 5 will be retained. 8 divided by 2 is 4. 6 divided by 2 is 3. And since we can no longer see a common prime factor with any of the 2 numbers here, then that's the end of our process. And to get the LCM, we simply multiply 3 by 2 by 2, or the numbers on the left side and also the numbers below, times 5 times 4 times 3. And the final answer will be 720. Now to check if this is correct, divide 720 by 15, by 16, and by 36. And if you got a whole answer, then that means these 3 numbers will meet after 720 minutes. And aligning it to our problem, 720 minutes times 1 hour over 60 minutes. That gives us 12 here, cancelled, and then 12 times 1 hour is 12 hours. And to find our final answer, if the bells started to toll at exactly 2 o'clock p.m., then after 12 hours, that would be the next cycle, since that's half of a day. So 2 p.m., that means the next time they will toll together again will be 2 a.m., which is 12 hours after 2 p.m. Here's our next problem. Chris needs to pack 171 pens, 63 pencils, and 27 erasers into identical gift bags so that each item is equally distributed among the gift bags. Now find A, the largest number of gift bags that can be packed, and then B, the number of each item in a gift bag. Okay, I underlined the most important clue that we can get in the question, equally distributed, which means these numbers, 171 pens, 63 pencils, and 27 erasers, to be able to be equally distributed, must have something in common. that can divide these numbers. And that something in common that can divide these numbers is what we know as the GCF. So we need to know the greatest common factor so we can tell what will be that number that can divide all of these numbers. So we can ensure that they will be equally distributed in those number of gift bags. So let's do the math here below. 171, 63, and 27. Finding the GCF, let's divide it by their prime factor, common prime factor. And good thing all of this number has a common prime factor of 3. Okay, 171 divided by 3 is 57. 63 divided by 3 is 21. 27 divided by 3 is 9. Now, we won't stop yet because, again, we can still see a common prime factor, and that's 3. 57 divided by 3 is 19. 21 divided by 3 is 7. 9 divided by 3 is 3. Now, this will be the end of our process since 19, 7, 3 doesn't have anything in common anymore. Okay, so where will we get the answer for letter A and letter B? If the question is what is the largest number of gift bags that can be packed, then this tells us onto what is the largest number that can divide our items, pens, pencils, and erasers. And the GCF is actually right here on the left side, which is 3 times 3. Then that gives us 9. So meaning we can distribute our items in 9 gift bags equally. And if we divide it by 9, these numbers, 171, 63, and 27, we'll get to know the number of items in each bag here in the answer below. So there are 19 pens, 7 pencils, and 3 erasers in each bag. So that's how we interpret the values in our solution. Okay, so that's it for our second example. Now for your task, just to check your understanding, here's our sample problem number 3. 2 race cars, car X and car Y, are at the starting point of 2-kilometer track at the same time. Car X and car Y make one lap every 60 seconds and every 80 seconds respectively. Question is, how long in seconds will it take for both cars to be back at the starting point at the same time? Now, again, if you want to challenge yourself, please answer this question. Then don't forget to put your answer in our comment section. Thank you for watching.